Let us start today another section of CSWIP 3.1. Chapter is on WPS and Welder Qualification, and I said to you when I finished chapter 5 that this chapter is going to be very important and very interesting because of the subject that it is. And of course, we are all going to become welding inspectors, so knowing WPS and Welder Qualification is one of the prime importance, and this lesson I think you should not forget for the rest of your life. So this is a very life-changing, important chapter. Let us see how this chapter has, what kind of details are there. I'm pretty sure that this is a very small chapter, 20 pages approximately. But the information that you will get when you are on the site or by talking to people, going through more detailed videos on the internet, on the WPS and PQR, you will have more idea. So this chapter basically is just a curtain raiser, or you can find this is as just has a macro information, not much in detail. But this chapter is very important for any CSWIP welding inspector going to be, or any mechanical engineer who is studying mechanical engineering. So let us see what is a welding procedure specification, WPS, and welder qualification, which we call WQT. So welder qualification test. So there are certain acronyms in this which you need to remember. For example, WPS, PQR, WQT, these are the things which industry is always speaking about, and one should know what are these kind of various things which are there in this technical jargon. So when structures and pressurized items are to be fabricated by welding, it is essential that all the welding joints are sound and have suitable properties for their application. What is the meaning of sound? Sound means fit for purpose and good. So in English, if you have a sound weld, that means it is a very good welding. So usually the English used here, people are not. I have seen that the mechanical engineering especially has students from all kinds of background. So their English is not so fine and perfect. And that's the reason these words here and there will confuse them. So, talking about sound welding, anyone will think about welding by a sound technique or something, but it is not like that. So sound in this case does mean that good welding, and should have suitable properties for their application. So wherever that is applied in the industry. So control by welding is by WPS, that gives detailed written instruction about the welding conditions that must be used to ensure that welded joints have required properties. Although WPS are shop floor documents to instruct welders, welding inspectors need to be familiar with this because they will refer to them when checking that the welders are working within the specified requirements and the range. So welders need to be able to understand the WPS and make non-defective welds and demonstrate the ability before being allowed to make production welds. So what does this paragraph mean? That the control of welding is by WPS. So the control by welding engineer, by the designer, and by the welding inspector on the shop floor, and the foreman and supervisors, everybody controlling the welder will be by this document. So if you see a written WPS document, it is just 1 or 2 pages maximum. It is crammed with information from the specification to code to client requirement. Now this page, if you make the WPS in actual form, it will become 10 pages. So all the technical jargon are very, very precise and concisely mentioned in this document. And if you go to explain this PQR or WPS document, it will take a lot of pages. So what we do here basically is 1 or 2 pages just by symbols, just by small letters. We try to explain technically what the welder is supposed to do about the joint that he is welding. So this is our controlling document. We will see all the current requirement, voltage requirement, all that ranges where the input heat calculation, everything will be as per this document. So we will refer to this document for any kind of welding being done by the welder. And also the welder, if he has any doubt, he has to refer to this document to understand about the welding requirement. So qualified welding procedure specification. So this is the WPS we are talking about. The WPS and PQR are two different documents. You must understand that first, that the mother document is the PQR, which the welding engineer will make before project starts. So before project starts, welding engineer will go through the MTO, the material takeoff of the entire project, and understand what grades are mentioned there, what thicknesses are mentioned there, and based on that, he will come up with the PQR list. So in this list of PQRs, if there is 10 PQRs required, 15 PQRs required, 25 PQRs required for that project, he will make a list of that. Then he will make a list of the PQR material that is required. And then of course, you can see my earlier video on this. I have explained it in very great clarity. So as is the practice in to use the qualified WPS for most applications. So one PQR may have 10 WPSs supporting that PQR. So this is what the welding engineer or welding inspector who is learning CSWIP 3.1, 3.2 need to understand that PQR is the mother document that is tested in the lab. Once that PQR is approved, the welding engineer within that parameter, within that range, can come up with 3 or 4 WPS suitable for welding application on the shop floor, depending on what they are welding. So a welding procedure is usually qualified by making a test weld to demonstrate that the properties of the joint satisfy the requirements specified by the application standard and the client and end user. So the PQR is first tested, as I said, by the welding engineer in the lab after the welding by the welder, and that will go to the lab for testing. There we will do the destructive testing. So you will go to the destructive testing chapter, and then you will understand more clearly all these things. So demonstrating the mechanical properties of the joint is the principal purpose of the qualification test. So what we saw in the destructive test class was that chapter was that the mechanical properties of the joint is the purpose of the qualification of tests. So that's why we are qualifying that PQR. But showing that defect-free weld can be produced is also very important. So the same way that the PQR is welded, in the production, the welder is supposed to do the welding within that parameters, within that range. So production welds made in accordance with the welding conditions similar to those used in a test piece should have similar properties and therefore fit for the intended purpose. So if we don't have PQR and if all the welders as per their experience of the past come and do welding, all the welding joints will have different properties, different mechanical properties. Some they will weld by SMAW, some will be welded by SAW, some will be welded by FCAW. All the welders will bring their own information into the job and past experiences, and all the welding joints within the company for the project will be different quality. And that is why, to avoid that situation, we have a PQR. So if you do a PQR, then all the welders follow that PQR. Then there is a standardization of welding. That means one iPhone, which is made in the China or made in India or made anywhere, will have the same standard. And that's the exact principle behind this, that the type approval of that one iPhone, you will make hundreds and thousands of iPhone. Same way, the PQR, when it is approved by the lab or the third party and all the document is out, then the hundreds and kilometers of the welding following that PQR will be standard form. So that is what we are looking for here, is the standardization. So typical table 6.1, typical WPS written in accordance with the European welding standard format, given details of all the welding conditions that need to be specified. So as per the standard AWS and European standard 15614, so all these standards will have their formats. So the format is basically again to bring the standardization. So if in project we have AWS, then all the people know the format to be followed. And if it is ISO standard, they know what the format is to be followed. They know where the current will be, where the heat treatment will be written, where the PWS steel will be written, where the gas is mentioned. so they will become easy and quick. So if every company will have their own format, so the format is very important for quick finding on the shop floor. So let's see this typical scope, how it happens. The typical sequence of the welding procedure qualification. So he's talking about here is welding procedure qualification. So when you talk about procedure qualification, PQR is procedure qualification record. So don't confuse yourself with welding procedure specification and procedure qualification record. When we are talking about PQR, it's the procedure we are qualifying. And after the qualification of the procedure, you can have many welding procedure specification from that PQR. So the welding engineer writes a preliminary PWPS, we can say PQR, preliminary PQR for each test coupon to be welded. So we usually call it as PWPS because before it becomes a PQR, it is in a form of PWPS. So welder makes a test coupon in accordance with the PWPS. Welding inspector records all the welding conditions used to make the test coupon, which is as run condition. So what current you used, what voltage you used, every pass, root pass to hot pass to fill and cap. Every pass we are taking the run sheet. And if you see the run sheet, typical run sheet, if you want, I will just post it here so that people will know what exactly is a run sheet. It's a very, very difficult job. We have to stand there till complete welding is finished, and the welding inspector, with the help of tong tester and a digital temperature monitor, will monitor the conditions of the welding. People usually prefer the CSWIP 3.1 candidates for such a task. So once that sheet is recorded, the test coupon is subjected to non-destructive testing first, and then it goes to destructive testing in the lab, which you have seen in the chapter 4. The test coupon is destructively tested: tensile, bend, macro, impact, Charpy impact, depending on the requirement of the codes and standards and the client application, and also the application. It is tested. If the PQR is passed, then the PQR is prepared by the welding engineer, and it has all the information attached to that PQR. For example, what electrode you use, the MTC of that, a material certificate of that, the material of the piece welded, that steel MTC. Then it will have the gas, if you have used any gas, that certificate. Then it will have the lab tested results attached to that. And then the NDT which was done for that, the NDT reports will be attached with that. In this one aspect, I want to make it very clear, and for our past lesson learned, if you are doing an AWS PQR and if you are doing 15614 PQR, these two are different standards. Okay, so when an AWS PQR is being qualified, you must ensure all the AWS standard is mentioned in all the reports. So what happens sometimes, by mistake, the PQR is done, the entity report comes out is in AWS standard, where the PQR is of 15614 ISO standard. So then there is a very grave mistake, and the client also can say that you guys are doing, you don't know standard, or what you are doing, you don't know. So it happened even in some cases from in the companies that I worked. We saw that the PQR entity reports and sometimes even the lab reports are not matching with the standard. So that once the PQR is made, the entity reports, you must have clearly checked each and every clause properly. It has to be on the same standard which we are looking to make the PQR. So the third party inspector who is involved, apart from our inspector, will also be witnessing all the testing, and he will also the sign off on the PQR, and that is very important because many times it is asked. Also, this one more, I will have to explain the third party involvement here. There are many types of third party involvement. If somebody is dealt with the shipping industry, then the marine class is involved. In this case, DNV Marine, ABS Marine, Lloyd's representative marine sites are involved. Usually that PQR which we are doing for the shipping industry for marine side is actually having more cost than the normal industrial standard which we are doing for AWS D1.1. So usually in marine class standard is also involved, and also AWS is involved. So you will have to write this dual class in your WPS PQR itself during the testing. So why I am saying this is, when marine class PQR is qualified, you can use that in industrial as well as marine. Whereas when you qualify only with AWS standard D1.1, and if you want to use that on any marine projects, you cannot use it. So this is a very important information which I didn't see in any video being done by anybody. So I just want to tell you guys, these are the various nuances in the industry. So for example, you have a project where there is no marine involvement, and you will do a PQR with AWS, your client is happy, that project is finished. Then comes a marine, you want to build a vessel, or you want to build something like a small ship or something, then that PQR you cannot use for the marine class. The project will not allow you, because first of all, the third party involved will not be marine who is signing off. He will be from industrial background, and that is not approved by the marine class surveyor. So this is and that the cost is also less for the industrial applications. So this is the shade, one need to understand this. This kind of difference is there in the PQRs during even the third party involvement when it is. So third party, you have to choose it very, very carefully depending on your business, what kind of business you are going to do. Because running the PQR, if you have a marine class PQR, for example, and if you are doing marine projects a lot, you can reuse that as it is. Only if the standard has changed, then you just have to do some additional tests to satisfy that. But if you have this kind of problem that in your company both kind of projects are there, then you have to check with management what is better, what costs, because naturally the marine cost is slightly higher. Even the welder qualification cost is slightly higher in marine standard than the normal industrial standard. So building standards for the procedure qualification, European and American standards have been developed to give comprehensive details about. We will come out with a video where we will be explaining the PQR with respect to AWS D1.1 and 15614 ISO. So I will have a building engineer who will have come online and explain us the difference between these two. So with respect to standard, for example, during the test, if there is any different tests are involved, in any entity is different, what clause exactly to be followed. So we will come up with another video on that, because that will be in itself a standalone video. And I don't want to mix these things up, because in the video the length becomes too much to handle. So how a welded test piece must be made to demonstrate joint properties. How a test piece must be tested, which welding details needed to be included in the WPS, then the range of production welding allowed by the particular qualification test weld. So all this will have in the standards. So the principal European standard that specifies this requirement is 5614, as I have already been telling you. This standard you need to go through very detail and also study this, because when you will go to the job, this standard is now the most widely used after AWS D1.1. So any European projects will come, they will insist on 15614. Then you will write AWS D1.1. Probably they will not accept that PQR. Many times I have been asked whether I can write their AWS also and 15614 also. Well, what will happen in this case is very complicated. If you want to make a 15614 and AWS both standard PQR, then the NDT must be done in both the standard, the testing must be done in both the standards, and the guy who is witnessing needs to be a notified body for European ISO standard, and whereas in AWS, I think he can also sign off. So this is the nuances between the PQRs. Of course, yes, you can develop, but additional tests will be required. So that test you will have to do, you will end up in doing 2 test pieces instead of 1 piece, because obviously the test specimen will not be able to take from 1 piece alone. So anyway, the cost is going to double, but this cost exercise the company must do. But I have seen many AWS clients accepting 15614, but whereas the ISO standard usually doesn't accept AWS. So this is the the nuance in these kind of things. One need to understand that. I've seen many videos on this topic, but no one covered that particular aspect, and it's a very critical aspect in this industry. So let's see what is inside the 15614. It's part 1 and part 2. Arc and gas welding for steel and arc welding for nickel and nickel alloys. And part 2 will contain arc welding for aluminum and its alloys. The principal American standard for procedure qualification are ASME section 9. You can do it by that. For usually the pressure vessel manufacturer will do it by ASME section 9. And the structural welding, where people who are doing only normal structural welding, let's say for instance Saudi Aramco jackets and topsides, they all use AWS D1.1. So if I am sure that only the Aramco project I have, then I will go with the AWS D1.1 standard and do all my structural welding as per that. Then D1.2 is structural welding code for aluminum. Mostly not used in my industry at least, but I have very small experience in doing welding of aluminum vessels, small vessel. When I was in Dubai dry docks, we used to make aluminum vessels. So that is one of my small, in my small career, I have a small experience of that. Let's see the qualification process for the PQRs. So although qualified WPS are usually based on test welds made to demonstrate the welding joint properties, welding standards also require or allow qualified WPS for some application to be written based on the others' data. So what does this exactly means? We will go through this. Some alternative ways that can be used for writing qualified WPS are some applications are qualification by adoption of a standard welding procedure, standard welding procedures basically, test welds previously qualified and documented by other manufacturers, qualification based on previous welding experience, a welding joint that have been repeatedly made proved to have suitable properties by their service record. So what does these two items mean? And there is a lot of confusion in the industry about this. So welding engineers of that company need to have a PQR of that company. You cannot use the PQR done in another company, another owner, another company in your company, because that is not allowed as per the code. So code says that every company must have their own PQR and WPS, which must be done in that site. It must be tested in lab, and only then it becomes company property. So what is meaning of adoption? Adoption means you can copy the data, but you need to run the PQR. Let's say with somebody has welded let's say structural beam or plate, and that exactly matches your requirement. So no problem, you can copy the WPS PQR data, but the current, the voltage, all that you cannot copy. You can simply make a test piece and you have to record what you have got with your welder, and only then you can it will become your company's property. So the qualification based on previous experience also means the same thing basically. So if you have done a plate or a pipe somewhere in another company, you can use that data and come up with but you will have to run a test coupon in your workshop. So procedure qualification to European standard by a test weld, similar in SME section 9 or AWS, requires a sequence of actions typified by those shown in table 6.1. So what we saw in table 6.1, we will have to run that those sequence. Successful PQR is completed by production of PQR, WPQR, as an example which is shown in figure 6.1. So what we saw in 6.1, that matters. So PQR record number. So this is a typical PQR which anybody must have seen. So it will have PQR number, most important, because when in the shop floor we always talk in terms of WPS and PQR number, revision number, date of when it was run, then let's just make it a little bit bigger, third party involved, reference number, codes and standard, the most important. Then the address of the location where the company is situated. So the extended, then the joint type, parent material, coupon thickness, outside diameter. All this you will be mentioning in your. So there is as per AWS and 15614, you have got a format for this. So that format should be used. So the relationship between PQR and WPS, as I spoke to you. So once a PQR has been produced, welding engineer can write qualified WPS, which is again he has to sign it on that, and he has to the third party has to sign on that, or even many cases I have seen that the third party may not sign, but it has to be certainly approved by the client before you start the welding on that WPS. So for various production joints that need to be made. So the welding conditions that are allowed to be written on qualified WPS are referred as qualification range depending on the welding conditions used in the test piece as run details and form part of the PQR. So what you will run the specimen in your lab, in your factory during the welding, whatever you will take the qualification, whatever range of the current and voltage you will take will come on the PQR and WPS. Ultimately, the welder has to abide by that. So the welding conditions are referred to as welding variables by European and American welding standards and are classified as either essential or non-essential variables and can be defined. So essential and non-essential variable are very, very important aspect of the work. This defines the boundaries under which the welder will work. So essential variable means variable that has the effect on the mechanical properties of the weld met, and if changed beyond the limit specified by the standard will require WPS to be requalified. So what happens sometimes in the shop floor, we find that the welder has done some mistake, and that mistake, if it is an essential variable, then the client will ask, okay, that mistake has happened, open an NCR and qualify this procedure so that if it passes, that weld will be okay. Otherwise, that weld will have to be cut out. So there are many essential and non-essential variables. Inspector must by heart that, because it is the most asked question during the interview, and depending on that, there are many technical details, very fine details about the essential and non-essential variables. So as per the codes, essential, non-essential variable, there is a table, and that table you can refer to for the welding process. What are the and even for the welder qualification, what is the essential, non-essential aspects. So non-essential is a variable that must be specified in a WPS but does not have a significant impact on the mechanical properties, and that the welder can change depending on the situation. So the weldment can be changed without a need of requalification. So any changes in that, the WPS will not be required to be requalified. So it will be a safe operation. Because the essential variables can have a significant effect on the mechanical properties, they are controlling variables that govern the qualification range and determine what can be written on the WPS. Okay, because the essential variables can have a significant effect on mechanical properties, they are controlling variables that govern the qualification range and determine what can be written in a WPS. So if a welder makes a production weld using conditions outside the range given on a particular WPS, there is a danger that welded joint will have different properties than what is required. So there are two options: make another test using the similar welding conditions to those for affected weld and subject this to same test using relevant WPQR to demonstrate the properties still satisfy the specified requirement. मैंने जो आपको बोला था कि in case the welder will weld something which is beyond the required parameters, then the welding engineer will have to make another PQR with the same conditions and get him qualified. So हमारे company में for example ऐसा हुआ था कि the welder, instead of 6G R welding, he was qualified to 6G and he did 6GR welding. So naturally we try to get him qualified by 6GR by giving a coupon. Then he got approved. Then that weld also got approved. But it was an NCR. So naturally you'll have to understand all this. Otherwise you'll have to remove the affected weld and re-weld the joint according to the conditions of the WPS and make sure that the NDT passes. So most of the welding variables classed as essential are the same in both the European and American welding standard. So almost both of them are unanimous that they both have the same essential variables, but their qualification range may slightly differ because of the standards are different. Some application standards specify their own essential variable, and it is necessary to ensure that these are considered when procedures are qualified and WPS is written. So if you want to use AWS qualified PQR and you want to do some other standard welding, then you must see that the PQR and that standard has essential variables are same as your PQR. Otherwise, then the PQR will not be accepted for that standard. Example essential variables as per the EWS. EWS is European welding standard are given in 6.2. This is a 6.2. So usually welding process. So a range since the process qualified is SMAW or TIG or FCW. For PWST, joint tested after PWST only qualified PWST production joint. Joint tested as welded only qualify as welded. So as welded matlab if you don't do any PWST, it will be qualified for only normal welding. If you want to qualify PQR with PWST, you will have to do the PWST. Then you have to do the testing of non-destructive testing. Then your PQR will be qualified for PWST also. If you are doing PQR and then you are doing PWST after that job, then that PQR, if it is not having PWST, then it will again be necessary variable, essential variable, and you are doing something wrong about that. So I hope you understand this condition. So parent material type. So parent material is also very, very important. The P1, P numbers are very important. So parent material of similar composition, mechanical grouping properties have the same mechanical group number qualifies, only allows production welding of material with same group number. So if the same group number of P number and the same group number what you have welded, you can go to the AWS. There is a table there which explains this particular precise condition. Then welding consumable. So welding consumable for production weld must have the same European designation. So that is another important thing, that the welding consumable must be same. So material thickness, also the material thickness range allowed, you will get to know from the standard. Type of current. So here also the polarity is very important. So polarities are the important factors. So if you want to change the polarity of the electrode, then obviously it will be an essential variable. Then preheat temperature is very important. So meaning whatever preheat you have given in the PQR, you must be applying the same in the production weld. Then interpass. The interpass range of temperature is also very important item in this essential variable, and the heat input. So when impact requirements are required in your code and standard, apply the maximum heat input allowed is 25% above the heat input, and when hardness requirement apply, minimum heat input allowed is 25% below the heat input. This is two things which are essential. So let's go to the welder qualification now, which is equally important than the PQR qualification. So one must understand the two difference. You are qualifying welders based on one PQR or many PQRs, but the PQR standalone has a different procedure requirement of qualification, whereas your welders can be qualified based on any PQR, because for welder it is not important for which PQR he is qualified, but for him it is the process. So for him, if there is a TIG process, you can use a TIG PQR. If you are welding a SMAW, you can use an SMAW PQR. So the use of qualified WPS is accepted method for controlling production welding. but only be successful if the welder understands and works according to them. So the welder need to have skill to consistently produce sound welds. So welding standard will have to be developed to give guidance on the test welds and required to show that the welders have the required skill to make certain type of production joints. So as we brought standardization in PQR, same way in welders qualification also is a standardization process, so that all the welders qualified for that PQR for that process will give a standard type of welding. So this is to test that. I must remind here that the welding the welder qualified is not based on standards. He is only approved for 6 months. So that you must understand, if he is not doing any welding in that 6 months, then he'll have to undergo a new fresh qualification. So many times what happens, the welder will go to vacation or leave the job, and 1 year he will sit home, and then if he comes back to work, naturally his qualification is not valid. You will have to retest him with a new test piece and redo the whole process. So welding standard for welder qualification. So which are those? Those are different from 15614. So let us have a look. So as per the ISO standard, 9606 is a preferable code for qualifying the welders for fusion welding. So part 1 steel is used, and 9606 part 2 is for aluminum. EN 1418 welding personnel approval testing of welder operator for fusion welding and resistance weld setters for fully mechanized and automatic welding. So this is with respect to automatic welding, we are using that standard. The principal American standards which are requiring is, D1.1 very well, and ASME section 9 is used for doing the piping and pressure vessel. So this is very, very clear that structural is AWS D1.1. And if you want to do piping or pressure vessel, you have to go to section 9. ASME section 9 deals with that welder qualification. Whereas in ISO standard, there is nothing like that. If you do 9606, then it can be good enough for any kind of welding. The qualification process, let us see that qualification testing of welders to EWS requires test weld to be made and subjected to specified test to demonstrate that welder is able to understand WPS and produce a sound weld. For manual and semi-automatic welding, tests demonstrate the ability to manipulate the electrode with or welding torch. For mechanized and automatic welding, emphasis is on demonstrating the ability to control a particular type of welding equipment. An American standard allows welders to demonstrate they can produce sound weld by subjecting their first production weld to non-destructive testing, which is maybe RT or UT. So table 6.3 shows the steps required for qualifying a welder according to the European standard. यहाँ पे मैं आपको एक बात बता दूं कि for Aramco these days, after 2018 especially, they have put an additional requirement for welders. So not only a NDT he has to pass, but he has to pass also a bend test. So bend test is already important requirement for a welder. So welders के लिए approval के लिए और एक टेस्ट डाल के उन्होंने मैटर को और भी स्ट्रिक्ट कर दिया है. So the welding engineer writes a WPS for a welder qualification test piece. Then the welder makes a test according to the WPS and the range. And the welding inspector monitors the welding to ensure that the welder is working according to the WPS. Whether he is doing preheating or not, whether he is doing interpass cleaning, interpass temperature, and also current and voltage settings, and also the essential requirements, essential variables. So all that he will check, and then an independent examiner, third party, will be witnessing all this. Then the test coupon is subjected to NDT in accordance with the methods of RTUT or MTPT. Then for certain materials, welding process, some destructive testing may be required, bend test, macro, like fillet joint macro and bend test. As I said, Aramco requires bend test. So a welder qualification certificate is prepared showing the welding conditions used for the test piece, and the range of qualification he is allowed. So WQT will have all that. And in the back side of that WQT page, there will be his extension. So every 6 months, welding engineer and third party will sign on that sheet. So if a third party is involved, they would endorse the qualification certificate as a true record of test. So not only front sheet they will sign, but back side every 6 months they will sign. So typical WQT, you can see test material and spec, what he has welded to what, plate or a pipe, or what is the grade, then joint design, backing, with backing or without backing. So to understand backing can be gas, backing can be a plate, backing can be even a welded root pass. So these three important aspects, every welding engineer must put it in his brain that backing means something from the back. So this can be three conditions. Either you can use backing gas, like in case of stainless steel. You can use backing material, like for example, if you can put a 2 mm plate behind the root pass and start welding the root pass, and that backing strip will always remain there forever if your design allows that, for that matter. Then the third condition is, if somebody 6GR will do the root pass or 5G will do the root pass, and some other welder will come and do the hot pass filling and capping, then that is also considered that the welder is qualified only with backing. That means that welder will not be able to do root pass welding. This is very, very important aspect of this. So you must consider that in knowledge for this particular welder qualification. Groove angle, root opening and root face, these are all having ranges. You can specify a range if you want in your PQR. Then the welding process, of course, this is the essential variable here. Then the F number and all that F number is written here with respect to filler material, designation, size, designation type, trade name, it may be Saab or maybe Miller or whatever. Then position, what position is qualified, preheat, of course, as per the PQR WPS, and all the electrical characteristics like filler material size, amperes, voltage, and then the runout length, travel speed, heat input, everything is mentioned in this document. Let's proceed further. A welder qualification and production welding allowed. So the welder is allowed to make production welds within the range of qualification, as we already know. So the range of qualification is based on the limits specified by the welding standard, or for the welder qualification essential variables. Defined as a variable that if, so that's a definition, a variable that if changed beyond the limit specified by the WPS may require greater skill than that has been demonstrated. So he's telling that if essential variables welding beyond that, that means the skill has changed. So the greater skill or the lesser skill, he will have to get qualified. Some welding variables classed as essential for welder qualification are same type as those classed for essential variable for PQR also. So for PQR also there is essential variable, welder also there is essential variable. Many times they are almost the same, but the range of qualification certainly will be bigger in case of welder. Many times we have seen the welder, if he does more than 3 passes and more than 13 mm, then he will be qualified to unlimited thickness. As you know, this is written in the AWSD 1.1. So example of the welder qualification essential variable is given in 6.4. So for the welder also, it's the same welding process, type of weld, parent material type, filler material, thickness, material thickness, pipe diameter, and welding position. So you have to buy out this. This will be for the rest of your life very, very important items. You may be asked in innumerable number of interviews, and it will also be important when you go to site for the observation purpose. So this you have to remember, PQR and WPS or essential variables for the welder. The period of validity for a welder. So let us see period of validity. As I said, that certificate needs to be confirmed every 6 months. So the welding engineer will confirm, looking at the database in the company, whether this welder was doing what kind of welding. Then he will sign off and then ask the third party also to sign. Many a case, third party may not be important that he needs to sign, but of course third party will see certificate whether the company welding engineer has signed or not. So every retest is every 3 years. The chosen extension method of extension must be stated in the certificate at the time of issue. So in that certificate itself it is mentioned what is the validity of the certificate. So retest every 3 years, validity for 2 years, provided that the welder is continuously working for the same manufacturer. Also manufacturer has the quality system as per ISO 3834-2 or -3. So what is ISO 3834? It's a welding system certification which some company or factory will have to take if they are executing the ISO standard projects. For example, our company, we have EN 1090 standard certification, and along with that we have taken ISO 3834 certification also. So that certification is a separate video on the subject. So how to do, what to do to take that certification and all is mentioned in we will come out with a video. So that is a very for those, for managers and above who are going to do qualification of their company, their process, welding process as per EN 1090 and 3834. But the prolongation of the welder qualification. The welder qualification certificate can be prolonged by examiner examining the body, but certain conditions need to be satisfied. So records, evidence are available that can be traced to the welder and WPS used for producing welder. So welding, for example, not just that the welding engineer is signing, there must be some supporting document like RT or UT report for that particular welder. Then only engineer can say he was doing welding. Engineer cannot just write हाँ ये welding कर रहा था बाबा, ये साइट में कर रहा था, वो साइट में कर रहा था, ऐसा नहीं है. वो साइट में उसका वेल्डर का कोई एनडीटी रिपोर्ट होना चाहिए. Why I'm saying this? That is the meaning that the third party has already done the NDT and there is on that joint number welder ID is appearing. Then they are considering that report as independent verification report and then saying it is he was working. So supporting evidence weld must satisfy the acceptance level for the imperfection specified in EU standard, basically ISO standard, and I have made under the same conditions as original test weld. So the position, everything mentioned, essential variables must be same conditions. Then only he can be continuously doing welding. So these are the tensile test, transfers and guided bend test for doing the welder qualification. Then the toughness tests. This is for the PQR, I think, yes. It's for the PQR tests which are recommended. Basically ISO 15614. This is the format for the test results. So the test results will be written in that manner. And this is the welder's certificate where all the details are mentioned. So go through this line by line. You need to know what is written where. With that, we have come to an end of the narrative part of this chapter 6. You can go through these slides, which will give you, basically some information already been done, but it will be good for you to summarize this, so that many times what happens, verbatim these words are picked up and they make a question of that in CSWIP 3.1. So many a times a 3.1 question will come from this answer and all that words. The monitoring heat input, this every inspector must know. So the calculations are there for this, amperage and all. Maybe they will give you one question where they will ask you to calculate the heat input. So that time you must know the calculations very nicely. So you should do this. Very important. You do as much as exercise as possible. So with that we conclude chapter 6. So we will meet people in back in the chapter 7, which is material inspection, another very important and critical chapter for CSWIP 3.1 guys. So goodbye till then, and thank you for watching our channel. So keep subscribed, and we will come back to you with more interesting topic one after another. Thank you very much.